In this tutorial, we are going also to continue learning how to use differentiation to find the equation of the tangent and normal to the curve f of x at a specified point. So now we are talking about tangent and normal at the same time. For this purpose, let's move to set of exercises 7H page 130. But before, we are going to remember exactly what do we mean. If you have this curve f of x and the point A, so the green line is the tangent to the curve and it's going to have this equation, and the blue line is the normal at the point A that is creating a perpendicular angle with the tangent, and it's going to have this equation as well that is marked in red. But we are going to consider always using the equation for the straight line, that is y minus y1 equal to m multiplied by x minus x1, where x1 and y1 are given, but the remaining is m, the gradient. The gradient for the tangent is different from the gradient for the normal. So let's go to set of exercises 7H, exercise number 5, page 130. This exercise is an examination exercise. For f of x equal 12 minus 4x plus 2x squared, find an equation of the tangent and normal at point where x equal minus 1 on the curve with the equation y equal f of x. Then we have f of x and we have a point with the value of x, so we are asked to find the equation of the tangent and normal at x equal minus 1. For better understanding, let's try to make a sketch so we understand how we are going to start working out this example or this exercise. Assuming that this is the curve f of x in blue, so we can say that the point A at minus 1 is going to intersect with the curve at the point A with the y ordinate that is unknown. So we have x equal minus 1 and we are asked to find first the value of y. To find the value of y for this point, then we have to substitute in f of x the value of x, that is minus 1. So we say f of minus 1 equal, we substitute minus 1 instead of x, then we get 12 minus 4 multiplied by minus 1 plus 2 multiplied by minus 1 squared. This is equal to 12 minus 4 multiplied by minus 1 is plus 4 plus 2 minus 1 into or squared is plus 1. This is equal to 12 plus 4 plus 2 equal to 18. So now we have the coordinates of the point A, that is minus 1 and 18. Now going back to the sketch, we are able to locate the point A. So to find the tangent at the point A, then we can apply the equation of the tangent, that is y minus y1 equal m multiplied by x minus x1. We have the value of y1 and x1 that are from the point A minus 1, 18. Then m, the gradient of the tangent, is equal to f prime of x at the point x equal minus 1. Then we have to find f prime of x at the point and substitute x equal to minus 1. Let's first find f prime of x. We have f of x equal to 12 minus 4x plus 2x squared. Then f prime of x equal, the derivative for 12 is 0 minus the derivative of 4x is 4 multiplied by 1, and the derivative of 2x squared is 2 multiplied by 2x. This is equal to minus 4 plus 4x. Let's substitute in f prime of x, x equal to minus 1. So we get minus 4 plus 4 multiplied by minus 1 is equal to minus 4 minus 4 equal to minus 8. Then the gradient f prime of minus 1 is minus 8. Now we can substitute this in the equation y minus y1 equal to m multiplied by x minus x1. Y minus y1, that is 18, equal to m, that is minus 8, multiplied by x minus x1, that is minus 1, minus by minus 1 is plus 1. So we get y minus 18 equal to minus 8x minus 8. Let's now rearrange this equation, or we can get rid of the minus 18 on this side by adding 18 to both sides. So we get y equal minus 8x minus 8 plus 18. This is equal to minus 8x plus 10. Therefore, this is the equation of the tangent line at the point A. So now we have many different variables that we just calculated. Let's summarize them so we are able to find the normal equation for the equation of the normal. We have a minus 118. We have the gradient of the tangent at x minus 1 is equal to minus 8. We have the equation of the tangent, that is y equal minus 8x plus 10. Now to find the normal is perpendicular to the tangent, then it's creating a 90 degree with the tangent. So now we can say that the equation of the tangent or the normal is y minus y1 equal to m multiplied by x minus x1, but m now is not the same m previously, so we write it m prime, so we know it's the gradient for the normal, where the normal is perpendicular to the tangent, and this means that the m prime is going to equal minus 1 over m, and this is the property of the perpendicular lines. Then it's equal to minus 1 over minus 8 equal to plus 1 over 8. So now we can substitute in the equation all the given. Y minus y1, it's minus 18 plus 1 over 8, the gradient of the normal, multiplied by x minus 1 minus 1 is plus 1. So now we can think about getting rid of the fraction by multiplying all of the equation by 8. So it's easier for us to look at the equation. Multiplying all of the equation by 8, we are going to get 8y minus 18 multiplied by 8 is minus 144 equal to x plus 1, because 8 multiplied by 1 over 8 is 1. Now let's rearrange the equation, so we get 8y minus 144, and we are going to move all of the terms on the other side to the first side. So it's minus x minus 1 equal to 0. This is equal to 8y minus x minus 145 equal to 0 is the equation of the tangent or the normal line at the point A to the curve f of x. After following all of these steps, we are going to be able to go to set of exercises 7H and try to solve exercise 3 and 4.